So we're now stepping into the Telecom Lab to mix the perfect potion for modern infrastructure deployment. Let's welcome our telecom experimenters to the stage. Mr. Ali Hanna, CEO of Tampnet, Valentin Polozenko, CTO, Tele2 Kazakhstan, Rashid Al-Ahmadi, CEO, Infrax, Nurettin Setinkaya, Network Infrastructure, CTO, Middle East, Nokia, Hazem Hassan, Regional Sales Director, Tejas Networks, and our moderator will be Ivan Skenderowski, CEO, Salience Consulting.
I promise this is the last panel from my side today. You're free after this. Welcome, everybody. Hoping to have an interesting discussion. The topic is certainly quite interesting. We're looking at this as an infrastructure-focused panel. We bring together leaders across the full stack of digital infrastructure, from offshore connectivity and subsea systems to national mobile networks, mission-critical fiber infrastructure, and the cutting-edge technologies powering it all. So the potion for the right infrastructure deployment, and as any good potion, is about combining the right ingredients in the right proportions. Now, we are looking at across our industry, deployment is no longer about just building faster and cheaper. It's about building smarter, more resilient networks, and in a way that it scales with the future demand. So today we'll have discussion on 5 essential ingredients. One is the proactive management tools. Number 2 is the AI-driven optimization. Number 3 is the evolving offshore connectivity landscape. Number 4 is automation for improved service quality. And finally, we'll be talking about challenges and opportunity with the infrastructure sharing. So we start with the first topic, which is proactive infrastructure management tools. We understand that the aim here is to move from reactive to proactive setup by implementing platforms that help operators detect, predict, and resolve issues before they impact network performance or they impact the customer. So they rely quite heavily on monitoring, analytics, automation, and so on. I will start from I won't call the vendor community, with the partner community. Nurettin, Nokia has been very active in this domain with, for example, predictive self-optimizing optical networks, the WaveSuite platform, right? And these tools are supposed to help be more proactive if you're a telco operator. Can you let us know what's the current state of the art in these proactive systems and what are the benefits? Maybe some specific case studies as well.
Good afternoon all. First of all, thank you for having me in this panel and also bringing such a strong group of leaders into this, digital ecosystem discussions. So first of all, I want to a little bit talk about how we see the industry evolving. During the day, we have seen that many discussions happening, of course, around AI. Many keywords, agentic AI, edge AI, and AI supercycle. When we look to all these development, we are seeing that quite high demanding requirements are now placed on the network side. We can talk about especially the latency, bandwidth, resilience of the network, and determinism of the network that we are deploying. AI networks are quite different than what we are having in the traditional deployments. In the AI networks, we are expecting more and more human to AI platform communication, machine to machine communication, even AI to physical world interactions. These are bringing different actually requirements on the network side that we need to adapt the whole connectivity stack from access to the cloud environment, even to the submarine cables connecting to the global infrastructure. From our perspective, in order to achieve this type of environment, there is a new actual entity is emerging, which is called Digital Infrastructure Orchestrator. This is a new entity which is actually designing, planning, and also integrating, automating, and operating the whole digital connectivity stack in order to have a consolidated intelligence grid to serve to the purpose of the AI workloads. So this is how we see the market. From your question point of view, actually, yes, what we see in the market is that over the last several years, there is a big evolution going from a reactive type of operations to the proactive type of operations. Even now, we are talking about more and more autonomous networks, going beyond one level. From our side, as Nokia, we are mostly following the TM Forum autonomous network framework. This framework is actually explaining how you go level by level to reach to a fully autonomous network. When we look to the global market, there is a sort of average in between level 2 and level 3 autonomous level globally in the telco ecosystem. From our side, we are working with our customers in the region, especially the GCC countries are quite ambitious to go into the level 4 type of autonomy in a very short time. In the region, we have some collaboration. You mentioned WaveSuite, for example. We had a collaboration with the telecom operator in UAE with DO to show how our WaveSuite AI platform can help for them to make enhanced planning and also, increase the accuracy of the overall network configurations once they reach into the configuration level. As a result of this activity that we have shown, we gained 50% of time from the planning, and we increased 30% of the accuracy of the configuration that we made together with DO. So this is all based on a single WaveSuite AI platform, which is mainly focused on the optical infrastructure. If we look to the other parts of the ecosystem infrastructure stack, from the access to the data center, you need to have the full visibility on the network, and you need to understand the traffic patterns, what's happening in your network, and based on these traffic models, you should model what will be the proactive actions that you will take in order to maintain the intended service levels. This is what's happening today. If you go to the next level, in the proactive systems, we talk quite a lot during the day about the agentic AI. Next to the agentic AI, we are seeing that intent-based networking is becoming quite crucial, where you are defining intents instead of maybe hundreds of parameters to configure the network to serve the purpose of your service. Intents are created just based on your definition of your service requirements. And the network is just looking what your service requirements are. Based on those requirements, it's checking the intent. If intent is met, everything is perfect. If there is some degradation on the intent, then with the agents that you define, you can take automated actions in order to control your service levels. So this is something already happening in our portfolio and in the industry with our partners, and we see the evolution is going to have full autonomous networks in the coming years.
And you're implementing it here with DO Telecom, right?
Exactly.
Yeah, very good. We've heard before Etisalat claiming to be a level 4 autonomous network, right? So how is the comparison?
Exactly. So the thing is, if you go from level by level, you need to think about different use cases, and you need to make your infrastructure ready for enabling these different use cases, which carry you from level 2, level 3 to level 4. And level 4 is a completely AI-assisted, platform.
So you're not giving me a number. Yeah, that's okay. We move to Valentin. You're CTO of Tele2, and from what I've learned, that you're already putting some tools to be more proactive in how you're managing your network. So can you give us a bit more details?
Yeah, okay, sure. So several thoughts on this. First one, proactive could be very, very traditional. For example, you do not need any AI or any system to go once a year to tower and check joints, check that everything is okay. You need to do it every year, and you should do it. If we speak a more intelligent thing about the proactive things, I could be skeptical a little bit on this, because any CTO can tell you that any NOC, Network Operation Center, or every Service Operation Center can produce any amount of events you would like to fix. And the main point is to have resources to fix it. Yeah? And that leads us to the main point for proactive and current situation, how to estimate them. What is more interesting, more urgent thing to do right now, to go and fix proactively, and go and fix this exact event which already happened. And so we try to approach this. That's why we have in our company in-house software, which allow us to correctly estimate all events and dispatch them, especially for the field engineers, which direction he should go, or they should go, in order to avoid the most impact, which is already existing or could happen if we do not do anything. And this system has some AI like start points, like we can foresee probability of overload or traffic jams or other things like this. But we would like to develop it more, so it's on the goal. And the success of this story is proved by the fact that this system was sold as a SaaS, service as a service, to our competitor. They use it also for several years and happy and pay us for this service. So that's maybe one of the examples how it can be.
Mm-hmm. And you've developed it in-house, you said?
Yes, in-house.
What's the reason for that? Is it because you could not get it from the market, or there was nothing matching the
Partly it
requirements?
happened historically, but if you compare in-house development and ready engine, there is pros and cons for each approach.
Right.
When you do in-house, you do exactly what you want from the scratch. If you buy the existing product, you buy very nice engine which can do huge amount of things. That the issue is that 90% of that you do not need,
Right.
but you will pay for it, and you will need to customize it.
Right.
But yeah, it could be. It's not like the religion, so we go this way. No,
Understand.
it could be different approaches.
Well,
I agree with you.
Think.
so we move to the second topic, which is optimizing infrastructure through AI. So in Telco dictionary, optimizing infrastructure through AI means using intelligent algorithms to either build the networks faster, or fix issue faster, or fine-tune performance, predict demand and failures. So the idea being to transform traditional network is to self-learning, self-healing, self-optimizing. I'll start with Hazem, Tejas Network. So why do you believe, and where specifically AI is creating real measurable value in optimizing network infrastructure, sort of beyond the hype?
Thanks, Ivan. Glad to be here. Glad to be part of this great panel. And glad as well to represent Tejas Networks. So Tejas Networks is part of Tata Group, and we are specialized into the end-to-end network infrastructure, fixed and the mobile. And if I can say one fact about Tejas Networks, that we are 65% of our workforce into R&D. So this is maybe the one fact that I would say stress on it. And I will start first with the title of the panel, if you allow me, Ivan. Potion. Because when you are saying potion, so this is actually resonates very much with the poor network infrastructure, the complexity, symptoms that the network infrastructure is having. So this morning we listened about how complex the network is being into the level of the resources that the network is requiring. And answering your question, Ivan, so is it a hype? So let's have an open discussions, or I would say open-ended question. How do we think the network is being evolving towards complexity, towards being hungry to the resources? So if we spoke about, I would say, starting from the architecture point of view, we I would say, learned from the colleagues in the morning that it is going into the edge. So it's coming more complex, more resources hungry, right? So this is from the architecture, and this is, of course, to comply with the business needs regarding the ultra-low latency, the high throughput. So all the discussion in the morning was related to the edge computing and pushing the network toward the edge. So this is one. Of course, we know the SBA with the 5G, the service-based architecture, it's not getting any simpler. It's going into cloud-native service, microservices, and all of that stuff. It's actually doing two things, making the network a bit complex and resource-hungry. So in line with that, back to your question, is it a pain or a need that we need to solve with the AI? Yes, the answer is yes. So the AI framework in TGS networks is actually started with a goal, with a clear goal in mind. What is the goals that we need to achieve with the AI beyond the hype? So in line with that complexity, in line with that, I would say resource hungry, we decided that from an network infrastructure perspective, two values that we need to focus on. First is how to run this network. How to run here means operating, like self-healing, troubleshooting, running mean operation in an extended level. So this is one. The second would be how to manage the network and how to manage it right. So again, managing here means planning, network design, capacity planning, all that full suites. So answering a long story short, Ivan, yes, there is a need. We decided in TGS that we focus with the goal because a goal is the first step before we go into the AI framework. We decided to have the first goal into planning, I would say planning values or planning as a goal, including all the running, as mentioned, use cases, operation, automation, and the planning and the operation, I would say.
Well, thank you. Now, coming to Rashid, Infrax, obviously you're a specialist IoT operator, and sort of what is the role of the IoT in optimizing infrastructure? You know, you've got the sensors providing information which effectively could fit into that AI engine. I think we had some discussion before. So what's your viewpoint on using your type of networks?
Absolutely. If you saw, most of the discussion today was regarding the AI. But when we go back to the role of telco, everybody is agreeing that the telco will always be positioned as a commodity, as an enabler. So that's why at Infrax, through the ecosystem that we created under the vehicle, which is called Digital Diwa, we have a focused arms that focus on certain requirements. So we have Moro Hub, which is a data center kind of a positioning where we are trying to enable the AI application and the clouds and the big data applications. And we have Infrax, which is the one that is fuel the AI, fuel the data center. And our objective is mainly really to connect the not connected and to really create the sort of synergy and harmony between the different touch points. If you look into the grid, for example, as we are a company owned by Dubai Electricity and Water Authority, we are fueling the connectivity of all our touch points when it comes to providing water and electricity. Through this data, we are able to correlate and synergize a lot of touch points when it comes to consumer services. So, for example, if we are looking for the smart grid, correlating that with the connected cars. Today, the grid needs to be equipped with the capability to know where to position the electricity demand, because the electricity demand today is not static. It's not only to the home. The electricity should follow where the car will go, because you need to know how much fuel left or how much battery left in the car, because you know if you will reach to the office, you need to charge, or when you reach to the home, you need to charge. So these touch points today need to be connected. And we took the focused approach to become an IoT service provider as an enabler with different type of connectivity, with different portfolio of services that allow the correlation of these touch points and fuel the AI applications and really create the value proposition of what we call smart city implementations, to what we call it as a digital transformation agenda. And we play a key role to partner with technology providers and with government entity to really look into how to connect that puzzle together and how to add the value from different segments, starting from the connectivity stack to the application stack, and then moving all the way up to the AI and the big data applications.
And I remember what you said, yesterday you mentioned, you might be able to, in the future, fine-tune the Dubai grid so that, the electric cars, once, they're in the offices, that's where the electricity might concentrate. And then, once they come at home, the load moves to the residential areas of Dubai so that the grid could sort of self-tune itself based on the information provided by
We
by
are
your
very
networks.
proud because Dubai Electricity and Water Authority is now almost 98% connected. And we're talking about smart meters, transformers, all the touch points when it comes to providing electricity and water. They are near real-time data that we can collect out of the smart grid. We are putting those data today in new business models that could create really value-added services, and we try to productize it with our partners to offer value-added services to our customers. This is go beyond the internal operation when we talk about self-healing grid. So for example, if there is a load on one of the transformer, we can reroute the electricity from another substations. This is go beyond looking into the weather situation to know how much we are going to produce out of Mohammed bin Rashid Solar Park, because now we have green sources to produce energy out of solar. And we know today it will be cloudy, so probably we need to move to legacy and conventional gas turbine generation, for example. So all of this will be able to be done or to be able to be enabled through a connected environment and through AI and implementation and correlation between different touch points, either from our network or even by integrating this with other data providers.
Very good, very good. And just quickly narrating from Nokia's perspective, which AI use cases might deliver the strongest performance for the telecom networks? Just few use cases.
Okay, so I just want to touch base two use cases. The first one is, with all these developments, AI ops becomes quite crucial in order to enhance your operational capabilities, supporting the human operators in order to bring the right configuration, right planning with the support of the AI platforms. This is something that we have been already bringing with our platforms, like, for example, in the data center environment. In an AI data center, if you give, for example, keywords of X number of GPUs, X number of racks, X number of data center switches, I need 1 gig connectivity, etc. If you give all these keywords, then it can provide you what type of configuration that you can make in order to, have a faster type of infrastructure configuration. This is the same for the fault detection phase as well. The second thing is, we are talking about digital twins. Digital twin for the network is also quite crucial. So it's the simply you are reflecting the physical environment in the network into a digital environment in order to see what might be the possible scenarios in the physical environment. And before implementing this in the physical environment, you just simply see the effects on the digital twin environment. If you actually enhance this with the AI capabilities, then AI started to learn from the digital twin. Digital twin provides your whole network capabilities, and it starts to learn, and based on this learning, AI can take actions in the physical network accordingly with the knowledge of the digital twin environment. So these are the two actual use cases that I see will bring quite a lot of efficiency in the network optimization.
That's very interesting, sort of the digital twin becoming a safe playground to experiment and stress test the network and then apply that into the real environment.
Exactly.
Now, we move to the third topic, which is offshore connectivity scene. Eli, your company's the largest offshore high-capacity communication network in the world.
It is.
On your website.
It is.
So, and you mentioned technologies from subsea fibers, 4G, 5G LTE, line of sight system. We also know that offshore networks operate in extreme conditions. So, from your side, what does resilient right deployment look for offshore in 2025, 2026? So, what are the technologies which are relevant, and what are technologies which might be coming in the foreseeable future?
long question. Okay, no, we are the largest offshore telecommunications network. I mean, the sea is 70% of the globe, and we cover the sea. So we own networks in North Sea, Gulf of America, Mexico, Trinidad, Mexico, Brazil, Suriname, etc. And what we do is that we own the subsea fiber, we deploy it, and then we overlay it with 4G, 5G line of sight, and then we incorporate also backhaul, sometimes LEO satellite like Starlink, OneWeb, Kuiper coming, etc. So to answer your question, when it comes, everything we do out there is mission critical. Mission critical from two dimensions. Mission critical from a public safety dimension, and mission critical from a geopolitical defense dimension. So you have two of them. So we are part of the Security Act. Our company's headquarters in Norway. We are part of the Security Act in Norway. We are part of, you name it, all the FBI, SEC, DOJ, etc. in the US that are very interested in what we do. I don't have access to this information. You need to be Norwegian and American to meet with them. I cannot meet with them, which is a blessing. No, but jokes apart, so everything we do out there is mission critical and needs to be mission critical. And then when we go out there, we need to go once. You cannot just go with trial and error. You need to do everything onshore and then go and do it once. So it's the whole game is different. The barriers of entry are very high, and that's why we are alone there. And then we kind of so we offer macro services where you have the operators like Du, Etisalat of the world roaming on our network, but then we also offer private networks, and this is where it's very important because that's what's enabled the automation, the AI, and we were talking about zero touch, full automation. All these oil and gas operators, they have a date in the 2030, 2035, where they want to have zero touch. And zero touch from a safety perspective, but also zero touch from an ESG environment perspective. So basically, when we do the private network, we make sure that it can operate in island mode. We make sure that we bring the core to the edge. We make sure that we have 100% coverage, because we go there to replace the push-to-talk systems and everything else into wireless. Yeah, I think for us, everything needs to have redundancy, not double, but triple and quadruple sometimes. And then when you operate in private network, in case everything is cut, you need to be able to still operate in island mode.
And hopefully you'll help us connect some of the scientific stations in Antarctica. Because,
just let me know. We're involved in the project in the up north, in the North Pole. There's a huge project going from Iceland around Greenland and then up there. But now they're fighting between EU, US, and everyone else. So we'll see how it goes.
Very good. So I'll move to the fourth topic, which is leveraging automation for improved connectivity. So we do understand that manual operations are costly. For years, telcos are trying to harness things like software-driven automation, orchestration systems, and network intelligence to enhance the performance of the network, make it more reliable, and enhance the user experience at the end of the day. So, Valentin, from your perspective, what is Tele2 doing in this domain, and which functions are ready for automation? And how close you are to zero touch? Maybe, some example also, if you can.
Last inch as every time, yes, so from the very beginning, so really. So every network, every year becomes more and more complex. New technologies, new spectrum, new services, and the traffic growing every year, hugely. And you need to adapt. The network should fastly adapt, should be trained and learn. So what we do in practice level, we again, sorry for this, but it's again in-house development. We developed our own self-optimization network, which I can say with proud already AI-driven, because it's analyzed the situation all the time, forecast where it could be overload or different traffic or some other anomaly, and produce the personal script for each base station or cluster with the new configuration. But the main point is that it can produce extra new scenario, which were not existing before by this training and learning. And here we come to a point what we can allow to AI to do automatically. Would we allow to use the script immediately and do it for the whole network? Not, we do not. So at this point, we check and test, and then we put to the library of different things which can be used by this self-optimized network for the future use. And so it's every day, 24 hours, 7 days a week thing.
Very good.
Thank you.
Hazim, from Tejas Networks, I mean, what are the OSS components from your side that enable this? And does AI play a part in your solutions to automate the processes?
Thanks, Ivan, for the great question. So maybe I mentioned at the beginning that Tejas is an end-to-end proposition when it comes to fixed and mobile or wireline and the mobile. And we are having actually a unified OSS, because OSS is maybe a wide terminology. It can cover from management to provisioning and so forth. So in Tejas Networks, we are having one unified OSS, or I would say that can provide the FCAPS, but this is not all. So when it comes to automation and AI, so we are having what we call triangle automation. So it starts with what we have, the top, or Tejas observability platform. This is the top automation, which is a role-based automation. And then we are having two supporting AI platforms that related to maybe the previous question that I was referring to, one for the operation and one for the planning. So the top is doing all the, I would say, automated, normal automation use cases in the network. So it starts with maybe interactive dashboard that you can just point, click, and drop down and select your dashboard. You automate, you interact, and create your own reports. So this is a simple, I would say, use case for automation. Second can be the KPI, I would say, anomaly detection, and the proactive and the preemptive as well. So you can see from the KPI if there is any, I would say, something that needs to be fixed out, then proactively from the trends, from the storage of the KPIs, then you can do a preemptive action. And finally, which is the agentic, and the agentic, as we all know, is related to augmenting the automation with a tool, with an action. So it can automatic, maybe sending alarming maybe signal, SMS, emails, even it can even generate a report. And then back to the two AI engines that maybe I referred previously. The operation one, which is Tejas Copilot, this is the one that is starting from the agentic AI. It can do self-healing. It can even do some sort of a search for a document. So if we are having a document, let's say training documents, let's say it is a knowledge base, to search on if there is any troubleshooting mechanism, so it can help us with that search engine. And then we take it like the next level can be root cause or RCA support. So it is, as you can see, it is some sort of a journey that we are taking the operation from the incident to identifying it. Then you are taking it to the root cause analysis, and finally, then there is a configuration assistant as well. It can generate, I would say, or propose some sort of configuration that can be automatically fed into the system. So that is related to the first one, which is the Tejas Copilot. The second one, which is related to the planning and the post-planning, which is the UFS, or we call it Universal Forecasting Solution. So this UFS is actually doing all the planning use cases when it comes to capacity planning. Let's say what is the current future resources in line, what is the current and future requirements. So capacity planning end-to-end for the network. Second, it can do as well intelligent routing for the traffic and route the traffic in an intelligent way. And finally, it will be supporting as well into the network design end-to-end and post-planning use cases.
Very good, very good. So we are coming to the last topic, which is one of my favorite, the infrastructure sharing, the opportunities and challenges. So we know that the sharing of infrastructure has been on the cards for a while, various level of success. So sometimes it's driven commercially, sometimes it's part of the regulation, which is trying to optimize assets of the country itself. and in some cases extends from telecom to utilities and so on. I'll start with Rashid. I mean, what's your experience in cross-sharing infrastructure with other utilities or between yourself and the telcos?
I think in the era of AI, despite that the sharing is one of the practices that is happening between operators. And I had the opportunity to work at DO and created the agenda of infrastructure sharing between DO and Etisalat. Moving toward the utility business, I found that there is a lot of abundant infrastructure and services that can be monetized and utilized to offer alternative communication means that can fit the current AI requirement. Starting with, for example, the demand that was coming from the hyperscalers today. So they are coming, they are consuming a lot of data center infrastructure, they require diversity from connectivity point of view, and as the operators sometimes share that infrastructure already, it doesn't make any sense to create adjacent infrastructure to fulfill one customer, so you need to find an alternative mean, and this is probably one of the options that could be offered by the utility because we have hundreds of thousands of kilometers available to serve the SCADA business, and there is spare capacity to be utilized. That's why we are working with the operators to create an offering that we can serve the data center ecosystem in Dubai, as an example. If you look, for example, from the facility infrastructure point of view, today everybody is talking about the edge computing and the requirement to move from the centralized to decentralized implementations of AI. And today AI requires two things, power and connectivity. And who's better than a utility business who have a huge resources of energy and a diverse spread of substations that serve the whole city to position as a one-stop shop, or we call it all-in-one substation, where you can serve your utility requirement, you can put your energy infrastructure, but also you can put a modular data center that can host an edge GPUs and provide the necessary energy for it and provide the fiber that can interconnect those edge with the centralized data center and also connect to the last mile customers or to create a standalone or a private 5G implementation. So we see the role of utility sharing their infrastructure for the next era of AI adaptation will be crucial because the operators today, they cannot really exhaust the infrastructure that will be served through the municipality or the government, and they really need to monetize the assets and infrastructure which is available, which has the resources and the necessary needs to implement their implementation and use cases. So that's why today one of the key focus that we have at InfraAccess is to create that kind of co-offering, and we are proudly working with the operators and some of the technology provider to position these assets and infrastructure in a way that could really enable the future implementation of edge capability and also provide the necessary connectivity with low latency, resiliency, and security, and the independency from the existing public networks.
And the utility infrastructure usually goes on a diverse route compared to the telecom infrastructure.
Yep.
And things like substations being points of presence for telecom purposes, they're intrinsically secure because the utility secures its network, and therefore, if you're using for telecom purposes, you've got physically secure network in a way.
Absolutely, and as I said, because the utility business already cater for that, we call it the OT network because the OT network is different from the IT. So that OT network is already utilizing the infrastructure in the same way that the telecom are utilizing their own infrastructure. So it's a good coexisting point for the utility and the telco.
Correct.
Besides that, the future demand today when it comes to the existing lands, for example, the resources, when we are moving to 6G, for example, if you need to deploy more towers. So all of these today will create a huge load on the municipality requirements of planning and also to utilize these lands for a new infrastructure. But if the infrastructure is already there, if the basis to create those adjacent infrastructure and parallel infrastructure is there, I think it's a good locations really to expand from the utility to a telecom kind of shared infrastructure where we can create business models together. We can serve the demand of the market, and also we can utilize it for, as we mentioned, our own smart grid and smart utility use cases.
Correct, correct. And Valentin, from a mobile operator perspective, and specifically in what you're doing in Kazakhstan, I understand you're already sharing RAN and with other operators and the spectrum itself. So what are the results and what have been the key challenges in achieving what you've achieved in Kazakhstan?
Yeah, by the way, thank you for this question because we discussed a lot of things about technology, AI, but partnership can make also miracles. And we did it, I believe. So just to understand, we really share on the very deep level. So we share the RAN and access up to spectrum. So it's also, we use it together. And how to compare it? We can compare it with marriage. You know that with a marriage, one household is more effective to keep than to do two households. But you need to share the values, you need to share the plans, you need to share strategy, and you need to find agreement all the time, even if you have different views. But if you do, it's impressive. For example, when we activated week by week golden network, golden grid, so like the network is ready, we understood which sites should be, we prepare the spectrum, and then one night we activate big city. In the morning, you can see that like average throughput for each customer, 30% more, traffic 30% more, you have 40% more coverage. When you put together, for example, low-band spectrum, you make the service in deep indoor good, perfect service, which before was like a service, but now it's a real service. And when you put together, for example, 100 megahertz and 100 megahertz in C-band, it's not like 1 + 1 is 2. No, it's 1 + 1 is 3, because it's absolutely different possibilities for this. So we strongly believe, and then when the golden grid is ready, the development itself, you invest $1, you receive the feedback for 2 and more. So this is interesting, and the competition still on the go, because not only on marketing level, you still have the different product. When you share the RAN, when you share the access, you still can have different approach, different architecture for the core, different approach for the data centers. Your data is closer to the customer. Do you have CDN network? Do you have caches? So, and can make the different, even measurable by crowdsourcing. So you have the same RAN, but different estimation of 5G, for example, product. That's how is it.
Very, very good, very good. And Eli, from your perspective, is infrastructure sharing something which is relevant for offshore networks? Are you doing any of that?
No, definitely. Sharing is caring. No, definitely, because of the very high entry levels, barrier to entry levels, then we share the network in multiple dimensions. I'll give you a few examples. For example, in Euro, we have a RAN sharing with Udido, which is one of the operators in Netherlands, where they use their basically roaming portfolio, which is the Deutsche Telekom portfolio, which is quite low, to roam like home when you're out there. Right. So if you have an Udido SIM card, or if you have any EU SIM card, you would roam like home in the sea, which is quite good. In AT&T, we have the same. They have a public safety network for the US, for the whole, from the government contract. So they extend it to the sea, and then they use their core and they use our RAN to give first access to first respondents. Then we are also negotiating with some oil and gas operators like BP or Shell to give them a core slice so that they would basically own a core slice on our network. We also do, now we are doing tests to have a GPU, CPU as a service so that we get a container on the rig and then all the Halliburtons of the world, instead of coming with their own servers and with their own, and then Schlumberger comes with their own, then we do GPU, CPU as a service. So yeah, we believe in sharing in all dimensions, and then we're happy. We have developed some sensors on our subsea fiber. University use it to check if the whales are coming across, and defense use it to check if submarines are coming across. So we share in all dimensions.
Right. Those are the smart sensors on the subsea.
Yes, SOP
And
sensor.
are you part of any consortium for a subsea cable where sort of you're reaching your sort of offshore installations and then the countries are utilizing the same?
So when it comes to O&M, to operation and maintenance for vessels, because it's very hard to get a vessel at the right price, we are part of an organization called ACMA. And then in that case, we are on the board of that organization. If there's a cut in the cable, whether it's a fisherman or something else, then we can get the... Okay, our record time to repair was like 12 days, which is quite good.
Yeah, very good.
Yeah. But as I said before, it's our network is not one place of failure. It's multiple. So even if one cable is cut, we still route the traffic through another way. And then one government asked me, "What if you have like the 4 cuts?" I said, "Then you have a bigger problem on your hands."
Right. Of course. Very good. I think we've run out of time. I don't know, Tony, do we have time for any question from them? No questions. Okay. Well, thank you very much for the participation. Very interesting discussion, and hopefully we'll continue the discussion.
Thank you.
Thanks, Steven.
Thank you.